Hey everyone, Simon here. So in this video, I'm going to show you how to prepare data for Geo-Surface Analyzer. And what I'm assuming here is that you probably have a shapefile with point data that you want to convert to be able to import it into Geo-Surface Explorer or Designer. So to do this, we're going to use QGIS. And if you haven't used it before, it's free to download. Just head over to Google, type in QGIS download, and just download the latest stable version for your operating system. If you haven't used QGIS before, first thing I would do when it first loads is go to plugins and choose manage and install plugins. And I'm going to get you to install plugin that is called Quick Map Services. So it looks like that. Okay, you type in Quick Map or Quick Map Services, and you're going to choose install. In this case, mine's an upgrade because I already have it. And it takes just a couple of seconds, and then you're going to close it. And once you've done that, what you should see is in your toolbar, you should see a new icon that looks like this. And the next thing I want you to do is just go to settings and then choose more services and then click on get contributed pack. Close out of that one. And now what you should see when you click on that drop down is you should have options for either Bing satellite, Google satellite, Mapbox satellite. Lets you add different satellite layers in the background, which is really, really useful. Now what I like to do, I'm just going to add Google, let's add a Google Hybrid as our background. So just choose Google Hybrid. I've got nothing else in my project right now. And the reason I do that here as well is because then it sets the coordinate reference system for the project to a global projected coordinate system, so everything looks the right shape and is the right way up, which is always good. So next thing, let's have a look. I'm assuming here that you have data in a shapefile format. Now if you don't have it in a shapefile format, if you've got a text file or something like that, you might have to just look at some YouTube videos or something, just how to import those into QGIS and convert them into a shapefile. But I'm going to assume that you have a shapefile, and I'm just going to drag and drop my sample shapefile in here. Now let's just zoom the map into the location. Just right click on that shapefile and choose zoom to layer. Now if you see a little question mark to the right of your shapefile, that may mean that it hasn't properly got the coordinate system defined and QGIS doesn't know the correct coordinate system. If you see that, you're going to need to click on that question mark and it'll take you to a page that looks something like this, and you'll need to define the coordinate system. Most likely your data is going to be in EPSG 4326, which is also known as WGS 84. If it's agricultural data, then you can almost guarantee that that's what it is going to be. And that's good and bad for what we need to do here. So first thing is, because you've got that imagery in the background, just make sure that it makes sense. Make sure that the shapefile is overlaid correctly on the location you expect it to be, because if it isn't, there's really no point in carrying on. Something is messed up, most likely with the coordinate systems of the data. The next thing to do, let's just check the data to make sure it actually has elevation attributes in it. So if you right click on the layer over in the layers area and choose open attribute table, and you should see the different attributes in the data. So in this case, this is Veris EC data, and we can see here that it does have an altitude column. So that's what we're going to use. And because it's Veris data, I know that those are values in meters, and we are going to want your elevation values to be in meters as well. I'll show you how to change that later if you actually have data where the elevation are in feet. I'll show you how we can do that. You don't need to worry about that now. So we've done that, and the next thing we're going to do now is we're actually going to need to create a new version, create a copy, if you like, of this shapefile, because we need to change the coordinate system. Okay, I don't want it to be in that WGS84 coordinates, because we need to interpolate it, we need to convert it from points into a grid, and in order to do that it needs to be in a projected coordinate system. It's not going to work if we try and do it in that base coordinate system. So what we're going to do is right click on the layer, and you're going to choose Export, Save Features As. Leave the format as Esri Shapefile, or if you've never used this before, it may default to GeoPackage, so just change it to Esri Shapefile. You need to click on this little box to the right of file name, and actually navigate to the location and give the file a name. Best practice is never to have any spaces or special characters in your shapefile names. And then here where it says CRS, we need to change that, okay? Because right now if it says 4326 WGS84, we actually need to change that. And the easiest way, just click on that little globe, kind of looks like an acorn icon to the right. And we're looking for a predefined CRS. You might be able to search for it. The easiest one to use is number 3857. So if you type in 3857, hopefully you'll find this one here, EPSG 3857. It still says WGS84, but this is a global projected coordinate system with metric units, which is what we want, and that'll work anywhere in the world. If it doesn't find it when you search for it, then you may need to come and look in here for projected, and it will be in that list. You just have to expand this a little bit. It won't let me do it because of my video is messing up my screen. But what you're looking for is EPSG 3857. So it should look like this, and you can leave everything else and just click on OK, and it'll create a new layer. So I can see over here now I've got my sample shapefile projected layer. So I'm actually going to remove the other one because it might just confuse me. Right click on that one and just choose remove layer. So now we only have our projected shapefile loaded, and it still looks good behind me. So now we're ready to run interpolation. So this is where we're going to create our smoothed grid and turn it into a GeoTIFF. So we're going to come up to the top menu, you're going to click on Processing and going to choose Toolbox. And if you type in the search box over here, interpolation, and it should open up the interpolation options here. And usually the best one to use for this kind of data is TIN interpolation, so it's a triangulation interpolation. So look for the TIN interpolation option and double click on that one. We need to set the parameters that we're going to use. So in this case, I've only got that one layer loaded, so that's my sample shapefile. And the attribute that we need to interpolate is, in this case, going to be the altitude. Now, depending on your shapefile, that could be different, but you need to choose the column that has the elevation data in it, and then you need to click on plus, so it looks like this. Leave the type as points. Come down. We need to specify the extent. We're just going to use the extent of the data. So what will happen is where you've got no data, it'll still fill it in. You just you need to make sure that you understand that the data is only going to be accurate where you actually collected those points. And over here, for example, it is going to fill this in with elevation, but because we don't have any data here, we can't rely that it's actually going to be remotely accurate. But it will still use it. So we need to define the extent. Let's just choose calculate from layer and just point it at your shapefile layer. So it's just going to take the rectangular extent of this layer, and that's what we're going to run for our interpolation. And then under pixel size, my default here is a little, that's 10 centimeters is going to be pretty, make it a pretty big file. We probably don't need something that detailed, and it may not load it anyway. So depending on the size of your field, I would say anywhere between 1 and 2 meters here. So I'm just going to, let's just do 1.5 as an example. Okay, so this will be 1.5 by 1.5 meters. So each pixel in the interpolated file will be 1.5 meters by 1.5 meters. So yeah, it's what, 6 feet? No, not even 5 feet by 5 feet, something like that. You can leave everything else for now. We'll leave the output as temporary and just hit run. And if we did it right, then it should look something like that. So you can see what we've done here is we've created this interpolated layer. This is where you'll also see how good quality your data actually are. If I just bring this back on top of the original, so to me it does look a little bit suspect. I've got a few bad lines in here, and this is fairly common if the data were collected with poor equipment, for example. This may not have actually been RTK. I'm just using this as a sample because this is the only data I have on hand at the moment. But again, keep a check on it. If you see artifacts in there like this, and like this, that definitely is a sign that this data may not actually be the best. So you should be looking for a nice smooth surface without a lot of that junk in there that I can see here. Also in here you can see we've still filled in these areas where we didn't have data. So again, when you're using this, just keep that in mind, that even though it'll show you elevation values in there, you actually really don't know what those elevations are, because it's just smoothed it from the surrounding areas. So let's assume that this was good and that we were happy with it. And we're now going to export it out in 2 different ways, okay? Because I'm going to show you just how to export it for both overlaying on the map, so it'll actually build that sort of 3D colorful terrain, and also for uploading to create the custom flow lines as well. So the first one will be, we're going to right click on the interpolated file. We're going to choose export and save as. Leave it as GeoTIFF, and let's just save it in the same location. Give it a name, whatever you want, and I'm going to call this one flow mapping. So this is going to be set up to work for the flow mapping tool. So we're going to hit save. And for flow mapping, we need a projected coordinate system. So that 3857 that we just used to create the shapefile, that's actually perfect. So we can leave that one as is. Make sure you're seeing 3857. Or if you're using a UTM, your UTM coordinate zone 10, 11, 12, 13, 14, whatever it is, then you can use that as well. Everything else should be good. We can leave it as add saved file to map if you want to. And the other thing I may do is if scroll down to the very bottom where it says no data values, just click on plus and just enter 0 and 0 in those boxes. So that should mean it'll not have a black border around it, but it may still. And we'll just click on OK. So now you can see we've created this sample DEM flow mapping. We're going to do one more. We're going to right click. We're going to choose export again on the interpolated layer. I'm going to choose save as. And this time I'm going to call it sample DEM for the elevation map. So this is the one we're going to load as our elevation map overlay. And this time we need to change the CRS back to that original format that your shapefile may have been in the first place, the 4326. Okay, so you can see here I've changed it back to EPSG 4326 WGS 84. Everything else can stay the same. And again, let's just put in those 0 values. It may or may not help. But let's just put 0 for no data and click on OK. So now we've got these layers added to the map, and you can't even tell that they're there until you start turning the different layers on and off. So it's a good sign that they look exactly the same. And now those, wherever you save them, should be ready to import into Geo-Surface. So let's just have a look. Okay, so I'm in the Canadian version because the data that I just worked with was Canadian. So then you're going to go to import GeoTIFF, and you're going to go and find the version that you just saved for elevation maps. So remember, that should be the one that you saved in the 4326 coordinate system. And click on open. And if it works, it should take a few seconds to load up, and then it should load and zoom to the field. So there it is. And again, you can see what I mean about some of those artifacts in that data. So personally, I wouldn't want to use that for any kind of drainage design, but you can see it is working, and it is using that data. And when I'm clicking, I'm getting those instant lookups. And it's also converted the elevation values to feet. Remember, the original data were in meters, so it is working. And the other thing that we could do as well then is actually convert that into use that to generate the flow lines as well. So if you scroll down on any of the paid versions, you've got the flow map generator tool underneath those the main tool. And what this does is it lets you upload your GeoTIFF up to a maximum of 15 megabytes. So if yours is bigger, then you may need to go back and change those pixel sizes. Remember, we set that pixel size to 1.5 by 1.5 meters. I think my file was about 10 megabytes, so it should be good. And in this case, we need to choose the option for flow mapping. Click open, and then we're going to upload and process. So what happens first is we upload the data to the processing server, depending on how fast your internet is. Once it gets there, it's going to start processing, and again, depending on how big the field is, it'll take anywhere from a few seconds to a minute or so probably to process. And once it does, it should give us the download. Okay, so that one actually took about a minute and a half to come in, and you can see it's prompting me now to download the flow routes. So let's just download that one, and then you'll be able to import that back in. So you need to do that using import flow routes KML. Do not use the import KML because it'll crash your computer. So go import flow routes KML, find the downloads, and we should find, there it is. So yeah, it's kind of messy because again, that was not very good data, and this is all a sign if you're seeing messy lines. And let me just bring in that HD flow again, or the elevation, sorry. So again, it's a good way to double check the quality of your data, but again, it is going to use that now. So if I run a manual survey, for example, over here, you can see it populates instantly, and it's pulling that data from the layer. So do really need to keep an eye. If it doesn't look good, it probably isn't good. It probably isn't good data. Garbage in, garbage out, as we say. Be very careful with what you are using. So that's how to do that. Final thing I'll show you here is, just in case, let's go back to QGIS. Imagine your shapefile data or your original data were in elevation units with feet, and you need to change those to meters to give you accurate values, because we expect the incoming data that we're using in Geo-Surface to always be in meters, and we actually convert it behind the scenes back into feet. So if you're bringing in data that's already in feet, it's going to assume that it's in meters, and you'll see really high elevation values. So the easiest way to do that is go to the raster menu with one of your interpolated layers loaded here. So let's say we wanted to modify the elevation map. Come up to the top menu, click on raster and choose raster calculator. And we just need to build a formula here to convert from feet to meters. Let's imagine that that data was actually in feet and I want to convert it into meters. So I will just double click on my sample DEM elevation map, and then we are going to divide it by whatever the meters to feet is. So I just Google it, or feet to meters rather. So I just Googled feet to meters, and 1 foot is equal to 0.3048 feet. So actually you can just multiply. Okay, so you do your equation, it would look like that. It would be your interpolated layer where the elevations are in feet, and then you multiply that by 0.3048. That'll get us to meters. And then we just have to save that somewhere. Again, let me just save it in my sample data. Give it a name. And output CRS, we'll just leave it as is. Let's hit OK, see what happens. So now we should have this new layer here called sample DEM meters, and you can see the values have changed. So now we've done the equivalent of converting from feet into meters, and then you would be able to import that one back into here. You can see there it is loaded again. Don't know what happened to my scale here, but you can see the numbers have changed, and it is giving us lower elevation values now. So that's a very, very quick run through on how you do all of that. And if you are looking at working with your own data to bring it in and use it in here, then you do kind of need to be a little bit up on exactly what it is you're doing, so you're not doing all of this blind. It's kind of a walkthrough for somebody that is already fairly familiar with using GIS and working with this kind of data. If you're having any issues, reach out to me and I'll do the best I can to work with you and see if we can get it working. So hopefully that was useful, and we'll catch up again soon.